everyone, welcome to my YouTube channel. And in this channel, in this video, we are going to talk about simultaneous equations in two variables using a matrix method, and that is what we're going to talk about. My name is KenMath, and we're going to talk about simultaneous equations. Now, when they say simultaneous equation, it simply means they're talking about equations with two variables. For example, we have got x variable and we have got also y variable. That's what they usually talk about. So we have got two variables and then also two equations. So two equations with two variables. That is what we call simultaneous equations in two variables using a matrix method. So that's what we're going to do in order for us to solve this simultaneous equation. Okay, so for example, if you have been given which is 2x, you have been given 2x and then plus 2x plus y, let me say y here. So 2x plus y is equivalent to 4. So 2x plus y is equivalent to 4, and then you have been given the other one which is x minus, which is 2x to y, equals, which is 2. So that is the equation that I've given us. Let me write nicely the 2. Okay, so this is 2. Okay, so this is the simultaneous equation that they have given us. So remember what I've said. I've said a simultaneous equation is the equation with two variables and also two equations. So these two variables, we have got x and y, and then we have got two equations. We have got equation number 1 and equation number 2. So what do we do? What are we supposed to do? Number 1, the first step is that we're supposed to make a 2x2 matrix. So we are supposed to make a 2x2 matrix. You put them in matrices. So say only variables 2, 1, there is a 1 here, and then there is a positive 1 here, positive 1, and then there is a negative 2. So we have got 2, 1, and then 1, and then negative 2. And then we'll say we have got the other thing. We have got the variables. So the variables also we put them in another matrix. So I'll say this is y. That is the other variable, and then is equivalent to, these are the other terms that we have. So these other terms we put them also in a matrix. So this is what we have. So this is the first step, to make them in 2x2 matrix. So this is the 2x2 matrix, this is a 2x1 matrix. Okay, so after that, what are we going to do? After that, we have to find the inverse of this 2x2 matrix. So we are going to say A, we're just going to name it as A inverse is equal to. So for us to find the inverse of this one, the first thing that we're supposed to do is to find the determinant. So for us to find the inverse, we have to find the determinant. So we'll say determinant is equal to the major diagonal, which is 2 times negative 2, which gives us negative 4. So it gives us negative 4 there, and then minus the minor diagonal, which is 1 times 1, which will give us 1. So our determinant, so we'll say determinant is equivalent to negative 4 minus 1, it gives us negative 5. So it will give us negative 5. So that is our determinant. And then that's determinant, we're going to say 1 for us to find the inverse, and then over negative 5, and then we find the inverse of this one. So we'll say 2, 1, and then 1 and negative 2. So for us to find the inverse of this one, we're going to say inverse multiplied by the minor diagonal. So we'll say negative 1 over 5, negative 1 over 5, and then for the inverse we have got For this one, we are going to swap. First of all, you swap the numbers which are, or the elements which are in the major diagonal. So say -2 here and 2 there. And then for these other ones, you multiply with -1. So we'll say -1 and also -1. Because when you multiply negative multiplied by negative multiplied by positive, it gives us a negative. So we have got such. So we have got something like this. That is for the inverse. That is what we have for the inverse. And then after we find the inverse, we're going to multiply both sides with the inverse. So we are going to start with, so we're going to say -1/5, then open brackets, we have got the inverse, which is -2, and then 1, and then 1, or negative, and then 2. That's what we have. So we multiply with the other matrix, the original matrix. So the original matrix is 2, 1, 1, and -2. That's the original matrix. And then we have got the variables. We have got the variables which is x and y. Those are the variables that we have. Okay. And then from there, I will say equals to the other side again, multiply with the inverse, so -1/5, -1/5 with the inverse, which is -2, -1, -1, and then 2, and then we close, then we open with the other matrix, which is 4 and 2. Okay, so that's what we have there. So after that we start multiplying. So this is a 2x2 matrix, this is a 2x2 matrix, this one, and this one is a 2x2 matrix. So we have got 2x2 matrix there, so meaning they can be multiplied, because I talked about following this number here. So this is 2 and also this is 2, so they can be multiplied. And then we say -1/5. So -1/5, we start multiplying those matrices row by column. So we multiply row by column. So say -2 multiplied by 2, it gives us -4. -4 plus -1 multiplied by 1, it gives us a -1. Okay, so that's what it is giving us here. And then to the other side, we'll say we'll multiply by column again, -2 multiplied by 1, it gives us -2, and then plus -1 multiplied by -2, it's positive 2. So it gives us +2, and then we close the other side. We continue with the row by column again, -1 multiplied by 2, which gives -2, it gives us -2 plus 1 multiplied by 2, it gives us a 2. And then row again multiplied by the other column, -1 multiplied by 1, it's -1 plus open bracket 2 multiplied by -2, it's -4. So that's what it is giving us. And then we'll say x and then y down in other variables. So these are the other variables. And then this side also we do the same. 1/5, we multiply row by column in the other side. So this side we have got 2 multiplied by 2, and then the other side we have got 2 multiplied by 1. So it simply means these 2 and these 2, they can be multiplied. Okay, so from there we start multiplying. -2 multiplied by 4, row by column, so it's -8, then plus negative 1 multiplied by 2, it's negative 2. Okay, so close, because there is no any other column this side. Negative 1 multiplied by 4, it's negative 4. 2 multiplied by 2, it's 4. So it gives us 4 there. Okay, so I'll continue to the other side. I'll say negative 1 over 5. I'll continue to the other side. So negative 4 plus negative 1, it gives us which is negative 5. Negative 5. Negative 2 plus 0, plus 2, it gives us a 0. Same applies to negative 2 plus 2, it gives us 0. So if they are the same signs, different signs and then same number, it always gives us a 0. So same signs, different signs, same number, 0. Negative 1 plus negative 4, it's negative 5. So it will give us negative 5 there. Then we close, and then we open the variables, which are x and y variable. And then we say I need to put here, and then we say equals, we start negative 1 over 5, negative 1 over 5, we open, negative 8 plus negative 2, it's negative 10, so negative 10 there, and then negative 4 plus 4, negative 4 plus 4, it is 0, because different signs, same number, 0. Then we start multiplying with this determinant which is outside with every entry inside. So negative 1 over 5 multiplied by 5, it gives us positive 1. It gives us positive 1. Negative 1 over 5 multiplied by 0, it gives us 0. Negative 1 over 5 multiplied by 0, it gives us 0. Negative 1 over 5 multiplied by negative 5, it gives us 1. We'll close, and then we open, we'll say x, and then y, and then we say equals the same, we multiply same. So negative 1 over 5 multiplied by negative 10, it will give us 2. And then again, negative 1 over 5 multiplied by 0, it will give us 0. And then from there, this is the identity matrix. So if this one, it gives us identity matrix there, then we are almost done. So let's just say x is equal to 2 and y is equal to 0. So we'll say x is equal to 2 and y is equivalent to 0. These are the answers of those variables. So let's replace. When we put on x 2 times 2 plus 0, it gives us 4. And then here we put 2 this times 2 times 0, it is 0. And then plus 2, it gives us a 2. So our answers, they are correct. So our answers, they are correct. If you want to prove more, we can simply replace where there is x, we replace with the answer, which is so we can say where there is x, we replace with 2, then or close, and then minus plus, where there is y, we replace with 0, and then equals to 4. And then this times that plus that, it gives us 4. So 4 is equivalent to 4. So it can be, those are the answers. Thank you very much for watching this video. Please don't forget to subscribe and hit the notification bell.